Today's lesson is on prime and composite numbers. We have some vocabulary you need to write down. First of all is prime. So prime number is a whole number with exactly two distinct factors, one and itself. So we went over factors yesterday, so hopefully you remember that one still. Our second vocabulary word is composite numbers, which are a whole number with more than two factors. It's pretty easy. So if I put both of these vocabulary words up here at the top, we're going to look through the first 5 numbers. 1, 2, 3, 4, and 5. And we're going to decide if they are prime or composite. And I'm actually going to go backwards. I'm going to start with 5. So 5. As you remember from yesterday's lesson when we found our factor pairs, we need to figure out how many factors there are. So if it has exactly 2 distinct factors, it's prime, and if there's more than 2 factors, then it's composite. So we always know we have 1 times our number, so 1 times 5 equals 5. Does 2 times anything equal 5? No. 3? No. 4? No. 5, we're right back to there. So our factors are just 1 and 5. So that would be exactly 2, 1, 2 factors, exactly 2 factors. So that's going to be prime. Let's look at 4. So we always know we have 1 and itself. So 1 times 4. Can we multiply 2 times anything to get 4? We can. 2 times 2. And we're back to 2 already, so we know we're done. So this has 1, 2, 3 distinct factors. We don't need to do the 2 again, because that isn't a distinct factor. That's the same as the other 2 we already have. So this has 3 distinct factors, which is more than 2, which makes it composite. Let's try 3. We have 1 times 3, 2 times nothing. So once again, we just have 2 distinct factors, which makes it prime. 2 is 1 times 2, and that's it. So we have 1, 2 distinct factors, so it is prime. Now let's try 1. 1 has 1 times 1. So we have one factor, one distinct factor, and then we have another one, but that isn't new. So this only has 1 distinct factor. So which is this one going to go under? To be a prime number, it has to have exactly 2. This has 1. To be composite, it has to have more than 2. So we're going to write this as neither. One is not prime or composite. It's in its own little special group. Okay, watch this problem. I want to know if this number is prime, composite, or neither. So 52. So let's find our factor pairs. We have 1 times 52. Is there 2 times something that equals 52? I know since it's an even number that there is, so it's 26. And here's the cool thing, I don't have to keep finding all my factor pairs. I already know that there are more than 2. We've got 1, 2, 3, 4. So I don't have to find all the factor pairs once I know there's more than 2. It's composite. So we're done. Okay, watch one more. We want to know if this number is prime, composite, or neither. And the number is 25. So I've got 1 times 25. 2, nope. It ends with 5, and that's odd. 3, nope. 4, nope, I know there's 24 and a 28, but no, 25. What about 5? 5 times 5. And we're back to our 5, so that is all the factor pairs. But there's 1, 2, 3 different, which makes it composite. Okay. Okay, this time we're looking for 7. So 1 times 7, 2 times nothing. 3, we've got 3, 6, 9, no 7. 4, 4, 8. And actually, once I've gone more than half of 7, there's no point to keep going because I'm just going to get up the opposite numbers. So 1 times 7 has 2 factors, which makes it prime. Okay. Here's your first question. You need to figure out if this number is prime, composite, or neither. So we start off with 6. Okay, your second problem, same thing. Is it prime, composite, or neither? And this time your number is 11. Third problem, same thing. Is it prime, composite, or neither? And your number you're looking for is 24. Okay, for your last problem, I want to know if all these numbers are prime, so I put blue for prime. Composite, I did yellow, or neither, white. So I want us to find 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Earlier in the video where we already did 1, 2, 3, 4, and 5. So 1 was neither. 2 was prime. 2 is our only even prime, because after 2, they all will have a factor of 2. You can divide anything even by 2. 3 was prime, and 5 was prime, and we also found that 7 was prime in one of our earlier problems. 4 was a composite, 6 is a composite, and like I said, anything that's even is going to be a composite other than 2. So 8, 10, 12, 14, all of those are composite. So what I want you to do is to figure out these last 4 numbers. And actually, 2 problems ago you figured out 11. I'm not going to tell you what that answer is, though, until you get to class tomorrow. So I want you to finish this chart up to 15. Tell me if 9, 11, 13, and 15 are prime, composite, or neither. And then bring this to class tomorrow. Thank you.